In this video, we're going to talk about 2.3, Objective 3, where we evaluate two-sided limits using limit laws and theorems. Let's go ahead and get started. There's lots and lots of examples for this, so I may actually make more than one video on the same topic, just to keep the videos a little shorter. Let's first compute the limit of g of x as x approaches 0. So that's going to be g of 0 is going to be 5. But when we stick a 0 in up here to calculate the limit, 0 plus 2 is 2. If the limit exists here, f of x and h of x, their limit's both 12. Find the limit of g. If it has to stay between the two, this is called the squeeze theorem. It also has to be 12. This is the squeeze theorem. It tells you if f of x is approaching this number here from from below, and h of x is approaching that number from above, and we don't care what g of x is doing that has to stay in between there. It has to, at that point, get close there. It has to get squeezed between those two functions. It has to go to the same limit there. Or find the following limit or state that it does not exist. This is a polynomial, so 12 minus 6 is 6. This is a polynomial, so 12 plus 4 is 16. Same thing here, 28. This is a constant function, so that's 4. I'm going to evaluate this one with synthetic division, just so I don't have to do all of the powers. 56, 61, negative 244, negative 236. That's it. 3, 1, 6, 7, 9, 27, 34. Okay, let's do some factoring here. Limit as x approaches negative 3 of 6 times x minus 1, 2x, x, let's see if there's an x minus 1 here, plus 9, 9 minus 2 is 7. Nope, that's not right. 3 and 3. Positive 6 and a negative 3. It doesn't really help me. But let's see, negative 6 minus 3 is a negative 9. That's going to be times 0 over 6 times negative 4. That definitely does help me. That's 0. Okay. Um, 10. Let's go ahead and stick it in here. So 64 over root 32 plus 49 minus 1 is going to be 64 over 81 minus 1. 64 over 9 minus 1 is 64 over 8. Should be 8. I can do that because it's within the domain of the original function. If we had found both 4b plus 49 has to be greater than or equal to 0, and square root of 4b plus 49 cannot be equal to 1, we would have figured out that this is within that domain. Let's go ahead here and do that again. 5 is within the domain here. 30 minus 5 is 25. And this is a negative 25. This is a negative root 25, which is a negative 5. When I stick 0 in for h here, I get 8 over root 25 plus 6. 8 over 5 plus 6 is 8 over 11. This is going to be 19. No, this is going to be 27 to the 4/3. Cube root of 27 is 3. 3 to the 4th is 81. Right, this is going to be limit as x approaches 1, x plus 1, x minus 1 over x minus 1. These will cancel. Give me limit as x approaches 1 of x plus 1. So 1 plus 1 is 2. So limit as x approaches 2, x plus 2, x minus 2 over x minus 2. It's going to be 2 plus 2 is 4. Limit as x approaches 5 of x minus 5, x minus 1 over x minus 5. 5 minus 1 is 4. Right? Limit as x approaches negative 4, x plus 4, x plus 3, x plus 4. It's going to be negative 4 plus 3 is negative 1. This is a negative limit. X approaches 14. X minus 14, I factored that negative 1 out. This is x plus 14, x minus 14. It's a negative limit. X approaches 14 of x plus 14. Because I don't have the negative on the outside, this is the same thing as a negative x minus 14 in here. So that's going to give me a negative 28 for my answer. It's the same problem. All right. If I were to stick b in here, this is going to be 0 minus 2b plus 2b over b minus b is 0 over 0, so I need to do some factoring. X minus b minus 2 times x minus b, x minus b, limit as x approaches b, it's going to be x minus b times x minus b to the ninth minus 2 over x minus b. This is limit as x approaches b. So that's going to be 0 to the ninth minus 2. 0 minus 2 is a negative 2. This is x minus b to the ninth minus 2. Similar problem here, x minus b to the 10th minus 4 times x minus b over x minus b. Limit as x goes to b. The limit as x goes to b of x minus b times x minus b to the ninth minus 4 over x minus b. It's going to be 0 to the ninth minus 4. 0 minus 4 is negative 4. Right, if we stick 2 in here, I'm sorry, negative 2 in here, negative 4 minus 3 is negative 7. Negative 7 squared is 49. 49 minus 49 is 0. Negative 2 plus 2 is 0, so 0 over 0 means we need to factor. This is limit x approaches negative 2 of 2x minus 3 plus 7 times 2x minus 3 minus 7 over x plus 2. Limit as x goes to negative 2 of 2x plus 4 times 2x minus 10 over x plus 2. Limit as x goes to negative 2 of 2 times x plus 2 times 2 times x minus 5 over x plus 2. It's going to be 4. Limit as x goes to negative 2 of x minus 5. Since they only have the limit symbol there, that's going to be the same thing as 4x minus 20. There is what goes inside. And 4 times negative 2 is negative 8. Minus 20, it's going to give me a negative 28. Let's pull the 4 out here. And as x goes to a negative 1 of 2x minus 4 squared minus 36. And then there's another 4 that can come out. When I pulled this 2 squared out, it's going to be 16. Limit as x goes to a negative 1 of x minus 2 squared minus 9 over x plus 1. So that's 16. Limit x goes to a negative 1, x minus 2 minus 3, x minus 2 plus 3 over x plus 1. That's x plus 1 right there. So 16, limit x goes to a negative 1 of x minus 5. It's the same thing as limit as x goes to negative 1 of 16x minus 90. And that's going to be negative 96. All right, let's go ahead and stop there before we start working on these difference quotient problems, because they're kind of a new topic that I want to spend some more time on in a separate video. So we'll come back right here and start with number 24 next time. See you for the next video.